So, warm welcome everyone. So, Fred Davis in 1989, with his research work, paper titled Perceived Usefulness, Perceived Ease of Use, and User Acceptance of Information Technology, he quotes, usefulness and the ease of use of tools comes with advancement in technology acceptance model. What it essentially means, if you observe his title, there's a keyword called perceived, which means the way we want to see certain things. When you say, when you have new technology coming into you, how do you want to accept it? So the way you want to accept is by understanding the usefulness of a certain thing or how easy it is to adapt to a new technology. So this paper has been the inspiration for me with my research work so far, and with this paper, since then, since 1989, there has been many other research works that is done to identify what factors, affects basically to, simply to acknowledge a newer technology, be it AI, machine learning, whatnot. So there is a certain factor that helps you to understand and perceive a newer technology to be accepted into your everyday work routine. So be it the demonstrability, determinability, relevancy, behavior, subjective, and these are certain other factors that has been identified. Unfortunately, the slides are not moving. Now you have. Yes. Thank you. So the paper, the talk for this title today is Actions in the Wild. Actions, by default, it's relevant to the GitHub Actions, what I'm going to talk about today. And again, specifically stressing upon usability and ease of use of open source security testing based tools. So that will be the main highlight for this talk today. As I said, so the key factor is the usability and ease of use of tools. So when you say an open source tool, what are the factors that you generally look at on how to adapt a certain open source tool? So with commercial solutions, you always have either one hand always in place, providing you with different solutions. But with open source tool, it's you as a user who has to take the first step, and from starting letter A to Z has to fulfill all the requirements. So this is the usability factor on how well can you adapt and what is the best performance that you can bring it to your own system. And with ease of use, it's a seamless integration to your own workflow. When you take a particular open source tool, how well can you adapt it? And when you say adapt it, that means you can integrate it and use it in your project. So my name is Rohan Krishnamurthy. I am a committer member for special interest group for Eclipse-based project called Tractor 6. And also I'm working for the exploit prediction scoring system from first.org. I'm also a member for OpenChain project working on the open source security tooling in terms of methods and processes. And my bread and butter comes from working full-time for ZF Group for Department of Technology and Infrastructure. So the talk for today will go through the project called Eclipse Tractor 6. This is the experience that I'm going to share on how different open source tool has helped me understand various factors and how it benefits every user. I'll also talk about different security activities across the SDLC and a myth buster about open source tools. Let's keep that as a myth until I come to that slide. And different best practices based on GitHub Actions and understanding different CVE and CVSS scores and what impact does it bring when you look at different criticality scores of high and medium and low and so on, so forth. And at the end, there will be a bonus slide. So let's stay tuned. So Eclipse Tractor 6, it's a reference implementation project of Catena-X Association. So previously, for roughly 2.5 years, it used to be a consortium of around 28 partner members. But since July 2024, it's an association right now. It's a decentral platform for automotive industry to exchange data in a secure fashion. It comprises of around 60 repositories for different product lines, be it real-time measuring systems, or be it the digital passports, digital twins, and so on. And there are around 250 contributors who are, day-to-day bringing the project into a betterment of the solutions. There are around 40 committers, including myself. We are trying to strive to, keep the data in a successful way. There are different guidelines that we need to adhere to. So this is one of our tasks as committers to make sure that the decorum is maintained. So for the Tractor 6, at least for the release guidelines, there are different chapters which helps you to maintain the scalability, to maintain the stability of all throughout your secure development process. So there are different chapters related to change logs for every release, about documentation about how to use Git, how to consider the Kubernetes clusters, and so on. But our focus for today will be the chapter number 8, security. So that is where we will, share my experience and bring you the best out of what I have experienced so far. So within this chapter, I share you the tools that I have used so far, and that is currently still active in the GitHub repository. For the static analysis, we have CodeQL, that is native GitHub tool. For the infrastructure as code scanning, I have Kix. And for secret scanning, you have Trufflehog. For container-based scanning, it's a tool from Aqua Security called Trivi. And for the composition analysis or the dependency management system, it's a Depend-About tool from GitHub again. So in the beginning, I mentioned there is a Mythbuster. Can you imagine what this could be? Okay, this is based on my personal opinion. You can quote me on that, but not necessarily for all the other commercial tools. So I'll be happy to engage you with my experiences and why I quote this on a certain stage and say that commercial tools would yield a secure and a safer product more than the open source tools. This is something which we commonly hear, or with the marketing from different commercial vendors, we hear that quite often. It is definitely true for features, auto-triaging features, and the dashboards and the fancy history that allows you to look back at 6 months ago, what was your the vulnerabilities that has been identified, best practices, and so on. But it is definitely not true for lesser false positives. I'll come to that point in the next slides. But so this is the myth that I want to take away from you, or let's say put this into a perception that I want you to understand and maybe think it from your own perspective. So here I have the CVSS scoring system. So the slides from now on will be the let's say the beacon of why I say that commercial tools are not something that they actually claim about. So this is the standard CVSS scoring system. So you have different categories defined for medium, high, and very high. And one of the tools that we used as a commercial solution, I won't want to name it because it's anonymous, but if you go to the project repositories and understand the range that is being used, it's actually quite high. So if you observe here, the high severity rating is generally standard one is between 7 and 9 and goes from 9 to 10 for the very high. But for the commercial tool that we have used for this particular project as one of our starting points so that we keep our development more secure, the high severity rating starts from 6, which is actually a center slab for the medium ones, which means it covers more vulnerabilities. And as a user or as a developer who are not necessarily a security specialist will obviously look at the number of vulnerabilities that has been identified, which in turn would mean it is making your product more secure, providing more vulnerabilities from the system. But that is based upon the number of vulnerabilities which are categories falling for high and medium. How this actually comes into place is because you set up general security policies within your project. For example, you say, I want to look at only high and critical ones for this particular release or for the next 2 releases, and I don't have enough resources who will look at all the medium vulnerabilities that are found. If you use the commercial solutions, they are clever in a way to identify little more than just high from the CVSS scores. But if you use different open source tool, for example, CodeQL, which I have used in this project, so they fall in the same range as that of the CVSS scores. And if you then try to evaluate, okay, I have a commercial solution and I have CodeQL as an open source solution, but the numbers are quite different from what actually has been identified. This could simply be because of the CVSS scores that is being targeted from the commercial vendors and what the open source solutions actually provide. Does it actually ring a bell? Have you actually looked back at what are the CVEs and how are the CVSS range actually provided by the by the commercial vendors? Maybe now it's a time that you go back. If you are using commercial solutions, see what is their CVSS scores range and if they match to the NVD scores or not. And if they're not matching with the NVD scores, are they matching the CVSS scores coming from different vendor-specific CVEs as well? One of the plus points after I use the CodeQL is on the right side. It was able to identify the cross-site request forgery attack even for an runtime URL. So within the TractorSX project, it's actually a decentral nature, which means it fetches the data at runtime for the URL, and CodeQL was able to find out that there could be a forgery of an attack for the URL. although it was not a true positive, but it was very useful enough that it actually helped the user to identify there could be a possible exploit. On the left side, you see, as a user, as a developer, this is something that will always trouble somebody as long as the same vulnerability has been identified within the same source and sink. That means all the injection attacks that is shown here is actually targeting the same source and same sink where the data is being tainted. So you can actually boil down to just one of the solution, and it would take away all the other vulnerabilities. So this is the pain point, but on the other hand, it is not about how useful it is in this case, or how easy is it to use, whether it is adding advantage to your workflow or not. So next example is the Trivi, which I mentioned for the container-based scanning images. So Trivi it does not use the CVSS scores coming from NVD, but it uses the GitHub Security Advisory database. That means the CVSS scores that is actually standard from NVD is revised from GitHub Security Advisory database and then given a new score based upon what could be the real impact into the GitHub hosted projects. So here you see both the medium or the very high categories are actually falling for the same range. But the trick is Trivi does not use the CVE scores coming from NVD, but they use the vendor-specific CVE scores. One such example is a CVE here, which is 40,897. So Trivi says it's a criticality of high, but NVD says it's only medium. Now, when you have security policies where you say we are only looking at medium-based critical findings, then you will definitely cover it. But if you say, okay, we are only focusing on high and very high vulnerabilities, is this CVE something that you need to address, or is this something that you can say it's not relevant for your own system? So what actually happens here is, with this different scoring system of the GitHub provided scoring system and the NVD scoring system, is what you need to understand what is the package version. For example, for this particular CVE, it's about simple setup tools Python package. So here they say for version number 65.5.0 and earlier, this is vulnerable. But if you upgrade it for the next version, it is safe enough. But the solution seems very simple, but we are not talking about the solutions here. We are talking about the approach to look at a problem. Here, two different scores allows you to understand what big of a difference is it coming from NVD and coming from GitHub, and understanding how should you look at a vulnerability, whether you want to address this or whether you are simply focusing on NVD scores and not simply ignoring other scoring systems, for example. So in this case, Trivi is simply out of the box taking the scoring system from GitHub. So let's break down how this scoring system for a same vulnerability from the same package is actually being differentiated. So here I have extracted the CVE scoring coming from the NVD and the GitHub scoring system. So these are the different vectors. So I'll just highlight on the one where the entire criticality is defined pretty much same for both of these, except for one. So here, the high and low is decided based upon how severe could the attack be based upon how complex the attack is. So if you have a least complex attack, that means the vulnerability is going to be high. And if you have a very high complex attack, that means the attacking scenario is rather low. That means you have a low, which basically comes from the GitHub Security Advisory database. So this is the only factor that basically determines on what CVSS score does it fall under. Now you as a user or a developer can obviously look into your project, say, okay, this is something that I can look at myself. So in my project or in this particular module, this is something that I can address as either something that is relevant that I need to address it, or is it something that you can ignore because it is not relevant. So with this, you will be able to understand and make a decision by yourself. When you also Google it for simply understanding on how to calculate a CVSS score, so there is a general way you can simply create a CVSS score by yourself. So for this particular example, this is how it looks. If you Google it up, you can also have an interactive one where you can select different metrics, and for your own project, if there are different CIA that you need to address. For example, in this case, you see the confidentiality and integrity is mentioned as none. But if you say, no, there is some integrity issue or there is confidentiality issue that I want to consider, keep it as maybe low, just to see the safer side in the worst case scenarios, then the scoring will be different. So this will allow you to understand on how to read a particular CVE and what impact does it belong for a particular CVSS score. Next example I have for the secret scanning tools. Very common perception is that when we talk about sensitive leak of the data or secret scanning, we generally talk about the passwords. Simple passwords like password 123, QWERTY, admin. These are some of the common names that we are generally used for testing purposes and even used at the time before going to the staging. So here we have tested out or basically evaluated 3 different tools, and one of my outcomes, or based on my experience, is that secret scanning is good enough to identify different passwords based upon patterns. It does not allow you to customize and create a pattern. For example, if you're using API key from bearer token, and if you want to provide a pattern, a regex pattern by yourself, it does not allow you to do so. Git leaks, on the other hand, it does not perform the sensitive data leaks through the cloud storages. So Trufflehawk, on the other hand, was able to do all these features with the ability to have the customization done. And for this particular project done at Eclipse Statistics, which is a decentral nature and making use of the cloud environment, so this was one of the perks, I would say, with respect to Trufflehawk. So that allowed you to understand whether there are sensitive data leaks and how the secret scanning can be useful. So coming to the last 5-minute section, so as I mentioned, there will be a bonus slide where I'll be talking about something new. So it's the exploit prediction scoring system. So on one hand, we looked at CVSS scores, and on one hand, we also looked at different CVEs. So what is this new EPSS? So is this something that is already known to everybody? Is it something that is already adopted? Is it something that is coming to still new, and whether we are sure of how benefit could this bring, and what is the effort behind this creation? So this is basically a data-driven module. So there are a lot of data that goes into it from this CVEs, and it provides a prediction scoring system in the next 30 days, wherein a particular CVE that has been identified will be exploited or not. And the probability is between a range of 0 and 1. The higher the probability, that means this particular CVE could get exploited in the wild in the next 30 days. So now this allows you to either do a cross matrix comparing with your CVSS score, saying that, okay, the CVSS score was rather low, but my EPSS score says it's very high because it could get exploited. Now you, as a user, can determine whether I want to consider this factor and understand what risk or what impact does it bring to my project, whether I want to address it right now or not. So this is one of the new added things. Right now, even in the GitHub advisory database, they are also using this score just below the CVE data details. For the CVE that I already addressed before, so this provides a probability score of 0.53. 0.53, which means it is a 50-50% chance that this vulnerability could get exploited. And down below, you see a 77 percentile. That is the percentile talking about out of the other vulnerabilities that are observed in this project, 75% of this chances of getting exploited. So where can you read this data? So this is generally your main user interface of the GitHub security advisory database. For this particular CVE, this is generally the point where you look at if this is a high score system for 7.5, this is the breakdown, and down below you see the EPSS score. So this is where the new addition has been done, not more than a month ago that GitHub added this feature. So I would appreciate if you want to understand CVE and its impact, maybe you can make use of all these opportunities and features where it brings more added value to your own project. With this, I want to conclude about my talk today about how you would perceive the usefulness of your tool and how is it easy enough to be integrated seamlessly into your project, and what benefits could it bring when you're using different open source tools. So this is again the quote from Fred Davis. I thank you once again for everyone paying attention, open for all the questions. Thank you once again.